Okay, in our next section, we're going to talk about some of the different applications of the network and some of the different requirements that they need of the network. And then ultimately, when we get into more details of the layer 3 specifics with routing and the layer 2 specifics of like Ethernet, the WAN encapsulations and wireless, how this is going to be affected by what type of application is running on top of the network. So as I mentioned before, this is always our ultimate goal with the network, is that there's some sort of application, whether it be web browsing or stock tickers for financial, that's going over the network, and we need to make sure that we're providing the correct level of service. So some of the common ones, I'm sure pretty much everyone's already familiar with them. Web browsing, IP telephony or voice over IP, which you're making your phone calls over the data network as opposed to a separate voice network. Video applications, whether this is real-time, like video conferencing with telepresence for Cisco, or whether it's non-real-time stuff like YouTube videos, for example. Email and database replication. The reason that we need to talk about the different types of applications is that they're going to be using different types of attributes of the network. When we look at things like the layer 4 information, that was the TCP or UDP protocols, we're going to have different services we can offer, like web browsing versus video, that we may want to use one network protocol versus another in order to deliver this. And the reason why is that different applications are going to have different requirements. And we could break this down into a couple different general attributes that they need, one of them mainly being bandwidth, or essentially how much data that we can send over the network at any given time. Where another one that is key for real-time applications is going to be the delay, where the delay basically controls, if I'm making a phone call, when I speak into the phone, how long does it take my voice to get to the other side, and then when they're talking to me, how long does it take to get back? Sometimes this is called the delay, the end-to-end delay, or the latency of the network. Now, it's key to note that the bandwidth and delay are two different attributes of the network, because you can have networks that are high bandwidth and low delay, or high bandwidth and high delay, or vice versa. You could have networks that are low bandwidth but low delay in order to service those individual applications. So for example, like a satellite link, let's say, that you may have tons of bandwidth where you can send a lot of data at once, but in order to actually get up to the satellite and then back, you're going to be subject to the amount of time or the delay the signal takes to get there and then to get back. So when we get into to more specifics of these protocols, we'll look at what we can do in the network in order to deal with these. Another one is going to be the reliability, where if we're dealing with especially real-time financial applications, we need to make sure that when the originating application is sending, like let's say a stock ticker or some sort of financial trades, that data actually does get to the other side within the time constraints that we're setting. Another one is going to be the security. So if we're sending some sort of corporate sensitive information, then we need to make sure that someone in the middle of the network is not going to be able to tell what's the actual data that's inside of that packet. So when we look at some of the different WAN technologies, we'll talk about the difference between using like a serial link with frame relay or PPP versus using different types of VPN connections that can add additional security levels into the network. And then also how we deal with security at other layers, like layer 2 Ethernet security or layer 3 IP security, things with like authentication and passwords at the actual network level. But with these different applications, based on how the interaction is going to happen in the OSI layers, which we talked about is like the interaction between IP and then a TCP header, or IP and a UDP header. The network can offer different levels of service, or what we sometimes call the quality of service, or the QoS, to the application, where we may find that something like voice doesn't necessarily need a lot of bandwidth, but it needs to make sure that it has low delay, so that when I'm talking on one end of the phone, that it doesn't take 5 seconds for it to get to the other side. So we'll look at when we see the different types of data going through the topology, moving between the switches and the routers, how we can deal with the requirements of the individual application based on different configurations that we can do on the routers and switches. Now, in order to understand how we meet these requirements, we first need to understand what the network flows actually look like. And again, this is going to be one of the main goals of this week, is that once we know how all the individual pieces fit together, that we can look at an overall network diagram and say if I'm moving traffic from point A to point B, at any given time, I know exactly what it's going to look like in the middle of the network and what the devices are going to look at inside of the data. Like, are they looking at the layer 2 header or are they looking at the layer 3 header in order to make their decisions. Now, the actual conversation between the applications, this is sometimes called the network flow, where the flow could be defined, let's say, as an individual client, a web client, downloading a page from a web server. Or a different flow or a different conversation, maybe someone making a phone call over that same network link. So the network is going to treat these different flows differently depending on where they fit into the OSI model. So where a layer 2 Ethernet switch, they're going to be categorizing flows based on layer 2 MAC addresses, or essentially the hardware addresses of the sender and the receiver. Where a layer 3 IP router may be categorizing the flows based on IP version 4 addresses or based on IP version 6 addresses. And layer 4 devices, they could even categorize the flows based on the TCP or the UDP data. So different physical devices in the network, like a content switch, for example, would be able to say, I don't care about the layer 2 header, the layer 3 header, the layer 4 header. I'm going to load balance my traffic based on web servers or between web servers based on maybe something that's going on at the application layer. So really, to figure out where an individual piece of the network fits in, we need to understand how it's making its decision on the traffic, or how it's treating the individual network flows. So this is going to be a big part of the job as being a network engineer, is being able to figure out what do the flows look like in the network, and when the device receives that data, what is it going to make its decision on, or how is it going to do its processing. So the difference between a layer 2 Ethernet switch looking at MAC addresses and what is known as the CAM table, or the content addressable memory, is going to control how it forwards its traffic, versus a layer 3 IP router that's going to use what's known as the routing table. Now we'll also look at, as the data is moving through the network, how is it going to change? So depending on if we're going through a layer 2 Ethernet switch or we're going through layer 3 routers, the devices are going to be changing data in the packets. They're going to be encapsulating and decapsulating individual portions, and we need to know when we're receiving that, what exactly is it going to look like. So let's say, for example, here we have a logical network topology, where the ultimate goal is that we want to get traffic to move from our client, which is up here, to get to this server. And let's assume that this is going to be a web conversation. So the web client opens up its browser. It goes to the server and it says, I want to get a particular page. Now, once it does this, the originating application is then going to start to send its packets down the OSI model. It's going to start at the application layer, go down, and it's eventually going to ask layer 4 TCP to start to build the TCP session. TCP is then going to ask IP to start to build the IP packet. In this case, assuming that we're connecting to the switch with Ethernet, the layer 3 IP layer is going to then ask layer 2 to build the Ethernet frame. And the Ethernet NIC card is then basically going to say send it onto the wire as the actual binary data, the zeros and ones. So we're going to come back as we go throughout the week and talk about different layer 2 functions and layer 3 functions, exactly how this is going to happen through the network flow. But from a high-level point of view, this host is going to say, in order to get my traffic from point A to point B, I need to send it towards this switch. Now when the switch gets it, it needs to figure out where do I actually send the data next in order to get to this device B. Because I could potentially send it this direction, I could potentially send it in this direction, and it's ultimately going to depend on where in the OSI model is it making its decision. Is it making it based on the layer 2 Ethernet header, or is it making it on the layer 3 IP header, or is it making it on some sort of higher layer decision, like the TCP and the UDP ports? Now, the majority of the functions we're going to look at on the routers and switches are going to be layer 2 and layer 3 functions, where the switches are mainly going to be dealing with layer 2 Ethernet switching, and the routers are going to be dealing with layer 3 IP routing, where essentially what's going to happen is that once the data gets to the switch, it has to figure out, do I send it to router 1 or do I send it to router 4? And the way it would need to do this is based on a layer 3 IP routing decision. And we'll talk about specifics later exactly why this needs to happen, but it needs to say, is it going to go to router 1 or is it going to go to router 3? And typically this decision is made based on a routing protocol, where the routing protocol is the routers in the network, like router 1, 4, 5, 2, and 3, talking to each other, telling them how the network topology is built. Where router 1 could say that I can get you to router 3 if you go this way. Router 4 says I can get you to router 5 if you go that way. Where router 5 would say I can get you to router 2, router 2 can get you to router 3, and then eventually I can get to this final server. But in cases that there's multiple paths through the network, like we have here, we could send the traffic from A to B this direction, or we could send the traffic from A to B in this direction. Ultimately, that's going to be a decision on a device-by-device basis, or essentially a hop-by-hop basis, where the decision that switch 1 makes, if I'm going to send my packet to router 1 or send my packet to router 4, this is completely independent of the decision that 4 makes that says, should I then send the packets this direction or this direction, and on and on and on. So ultimately, the interaction between the layer 2 network and the layer 3 network is going to be to decide on that particular physical segment that I'm attached to. So let's say between here, switch 1 and router 1 and router 4. There's going to be certain cases where switch 1 is going to send the traffic this way. There's going to be certain cases, likewise, that it can send it the other way. So we need to know, based on the different conditions in the network, how the layer 2 protocols are configured, like in the case of Ethernet, or the layer 3 protocols in the case of our IP routing. How are the traffic flows going to actually be sent? And then depending on the other attributes of the network, like if I were to use this serial link between router 1 and router 3 versus to go over this network cloud that could be like a frame relay connection or other WAN encapsulations like ATM or PPP, we need to take these different attributes into account when we're sending the final traffic from A to B. But again, the key here is that from the host's perspective, from A and B, they don't really care about the details that are going on in the network. They just say to the lower layers, I'm trying to get to B, it's your job to do that. Then from that point on, as us being network engineers, it's our job to figure out how the traffic is actually going to get there. So we'll come back to this example as we go through the different routing protocols and talk about how we can influence the traffic flows to say I want to go this direction versus going that direction, and the different ways that we can configure the network to do this, and then the different ways that we can test, did it actually get that result? So with different types of show commands, with different types of debug commands to actually look at the result of the traffic.